So this is a big bowl of awesome sauce if you're using newer hardware, hardware that supports a hardware clock. But what happens if you're on a device that does not have a hardware clock? And here we're on R3. I believe this was a 2600. We show the clock detail. It thinks it's February 25th, 2010. I want to see what the hardware clock says, so I type in show calendar. It says, I don't know what the hell you're talking about. So this means we do not have a hardware clock on this device. So are we boned? Every time that this thing reloads or loses power, are we going to be sent back to 1993? Well, the answer is yes by default, but there is a command that does help mitigate this problem. It's not perfect. It's not as good as having a hardware clock, but it does help out quite a bit. And that command is going to be the clock save internal command, and that's going to actually be a global configuration command, whereas a lot of these commands we were seeing were privileged exec commands. So we're going to go into configuration on R3, and we're going to type in clock save internal. We're going to ask iOS to help us through this configuration, and it says you can set any value from 8 to 24 hours for the clock backup update. Okay, let's go ahead and take 8, hit enter, bust out of there, and let's set the clock to the real time as it was when I created this, which was 25th of October, and we check our clock detail. Everything looks good. It doesn't look like anything magical's happened here since we put in our clock save internal command. So here's where the magic happens. When you issue the clock save interval command, what you're doing is you're telling the router that every X hours, and you can set 8 to 24. We chose 8 because that's the smallest value we could enter. So every 8 hours, what I want you to do is I want you to go take a look at your software clock, and I want you to take that value and write it into NVRAM. Now, as we all know from our CCNA studies, NVRAM is non-volatile RAM, so when a device boots up, it's going to be able to take a look at a value in this NVRAM. It's going to persist through reloads and power-ups. So that's going to save us from jumping back to 1993. We're not going back to epic time. So I go ahead and reload R3, and when it comes back, I do a show clock detail. The most important part here is that we have reloaded this device, and rather than going back to March 1st, 1993, we are still in the present, the relative present. There are a couple of quote-unquote gotchas with this, things that you need to be aware of, and here are the gotchas. So what it's doing, it's writing a value for the software clock into NVRAM. So let's say that your router reloads at 6 p.m. Let's say that it takes 5 minutes, which isn't out of the question for an old 2600, for iOS to get back up, get its brains, and say, I'm ready to start routing packets once again. So the time is actually 6:05, but your clock is not going to take that into consideration. It's going to say, I'm going to use the value that's in NVRAM, which is 6 o'clock. Okay. Great. So you've actually slipped. It's called slip or drift. So your clock is not exact. But, 6 versus 6:05, I'll take that instead of being sent back to 1993. I'd rather have a clock difference of 5 minutes, 10 minutes, whatever, than one of 17 fucking years. Cool thing with this command is that whenever you issue a reload, when it's a user-initiated reload like we did, it's going to go ahead and write the value prior to the reload. Now remember, we set up that command to write the value into NVRAM every 8 hours. And that's what it's going to do. But if you do a reload, it's going to say, okay, I know that you're about to reload this device, and I know that you want accurate time, so I'm going to go ahead and I'm not going to use that value that could be as old as 7 hours and 59 minutes. I'm going to give you fresh clock here. Let's go ahead and save this to the NVRAM. That's cool. But if you lose power, it's not going to do that for you. So if you lose power or some other unexpected outage, it's going to use the value that it last stored. And like I said, that can be up to 7 hours and 59 minutes old. If you set the value to 24, it can be almost a full day old. So keep that in mind. I think we handle that in the next slide. I might be getting ahead of myself. Okay, so we're on R3, the 2600. We take a look at the clock detail. It's got a good timestamp on it saying it's noon on the 26th of October. We go ahead and take a look at our uptime, and we've been up for almost 16 hours. So obviously I did this the day after I had configured this. So if I go in and take a look at the running configuration, I can see that I do have the clock save interval set to 8. Actually, the timing on this is pretty serendipitous because I'm at almost a 16-hour mark. So after 8 hours, the router said, oh, 8 hours is up, I need to write the time. And now it's 7 hours and 44 minutes later. In another 16 minutes, it's going to write the time again. But if I power cycle this device at this point, I don't do a reload, I just go ahead and flip the switch and power it down, it should use the last saved time, which is going to be 7 hours and 44 minutes old. So I even did this one better. I shut it down for about 30 minutes. And what should happen then is it's going to use that time from 7 hours and I'll just call it 45 minutes ago, plus it's going to lose the 30 minutes that's down. So the time it's going to use is actually going to be 8 hours and 15 minutes old. So here we go, we power it back on and we do a show clock detail, and sure enough we can see that the time here has now slipped. When we power cycled this, it was about 12:20. It's telling me now it's 4:35 in the morning. That's because that was the last timestamp that it had, was 8 hours after it had been up. So keep that in mind. This is one of the things with the older devices, is this clock persistence. It's nice. It's better than getting sent back to the early 90s, but it's not perfect. You can have pretty significant slippage on here. All right, so we've been seeing UTC in the output for the show clock and show calendar command, and it's time to kind of take a look at that. So UTC is Coordinated Universal Time. It's UTC, I don't know why it's UTC. It's probably because it's probably actually French. It's probably Universal Time Coordinated or whatever. Used to be Greenwich Mean Time. So basically, all time zones in the world are simply an offset from UTC. That's basically the clock that everything is set to. I'm in the Midwest. I'm in Minneapolis, and it's currently Central Time Zone, Daylight Time, so CDT. So my offset's actually going to be 5 hours from what it is in UTC. So you're going to want to set your clock and your hardware clock, if you have a hardware clock, to the accurate UTC time. And you can get that from the interwebs. Just go do a search on current UTC time and then set your clock to UTC. Now, for it to display accurately for your location, you're going to go into global configuration mode and you're going to issue the clock time zone command. And here we see that we have to put in a word. Well, the word is just going to be whatever the abbreviation is for your specific time zone. I'm in Central Daylight Time right now. And then the most important part is getting the offset right. And currently I'm 5 hours behind UTC. So I hit that, write it, do a show clock. And you can see here now, instead of showing me 4 o'clock p.m., it's actually going to go ahead and show it the accurate time here as 11:41 in the afternoon. So basically all it's doing is it's applying this difference to the clock and then changing UTC with whatever you put in here. And actually I probably shouldn't have set the time zone to CDT. We'll show in another couple slides how to actually set up daylight savings time. I should have set this to CST, which is Central Standard Time, and the offset should be -6. And then we would fix the daylight time bit with another command, which we will look at in a bit here. Okay, so there's a couple of things you need to be aware of when you're setting the time zone. And the first one is that the command is going to take the current software and hardware clocks and offset them by the amount that you specified. We had set up -5 hours. So prior to configuring the time zone, I do a show clock. It's showing UTC, and you have to watch out here. If you set your clock, you want to set it to the correct UTC time. Here I had set it to the correct central time. So then when I go in and configure my router to show my output in Central Daylight Time, -5 in this case, it's going to assume that the clock was in UTC, so it's going to actually set my clock back to 11. So if the actual time is 4:30 in Minneapolis, I don't want it showing up as 11. The lesson is to set your hardware, and if you have it, and software clock to UTC time prior to applying this configuration. The second one is that iOS does not verify whether the time zone word, in this case it was CDT for Central Daylight Time, actually exists. So you can put in time zone poop or boobies or go blow me, whatever the hell you want to put in there. It really just cares about the offset. So it's going to apply the offset, take whatever value you've written into the word, and then show that. So we can see that Mondays feel like it's on this time zone where it's 2:30 poop time, but the important takeaway is that there is no verification that your time zone abbreviation actually exists. So you can have fun with it, you can also get fired with it. And then third, and I touched on this earlier, iOS does not automatically adjust for daylight savings time, but there is a command for that. All right, and that command is clock summertime. Yeah, it's kind of a goofy nomenclature. So it's going to be another global configuration command. So let's go in, and this is how I should have configured this initially. Clock, time zone, Central Standard Time. So you want to put in your standard time zone, not your daylight time zone, and then the offset that it is during your normal time. So then the next command, you're usually going to do this in pairs, is you're going to type in clock summertime, and then you're going to set your time zone. So in this case, I'm going to use CDT. So CST when we're not using daylight time, CDT when we are using daylight time, and it doesn't verify that, so you can use poop and poop daylight time if you want. And the date bit might come in handy if you're not in the United States. If you're in the United States, all you have to do is hit recurring and hit enter. The router is going to know the date time rules for switching over to daylight savings time in the United States. So now if I go ahead and issue a show clock, October 26th is actually still during daylight savings time here. So it's going to show that with the time zone of CDT, and it's going to have an offset of -5. Now, if I set the clock to December 31st, 2010, that's outside of the daylight savings time. That's going to be our Central Standard Time. So now I show clock. You can see here it automatically adjusts for Central Standard Time. Because December 31st is in Standard Time, it's going to do that. And as I said, if you live in an area that does not follow the United States daylight savings time rules, you can set up daylight savings times on your device to use your local specifications. And these examples are taken directly out of the Cisco command reference for the clock summertime commands. Here you can see here, there's different ways to set this. It gives you a couple examples. You can read this on your own. Okay, and that's it. You're now dangerous as far as setting the time on Cisco devices. So just to summarize, Cisco devices all have software clocks that track the time. Some of them also have a hardware clock. You're going to want to have your devices keep accurate time across your network so that you can go back and correlate events, especially log messages across your network. If you don't have a method of maintaining a consistent time across devices, it gets very, very hard to troubleshoot. Now, you could be saved by the fact that you have a logging server, an SNMP server, and it's going to use timestamps that are local to that box, the server that is, and that might help you out. So you'll be able to correlate there. But if you don't have that, you're kind of boned, because if your times don't match up, it's going to be really hard to determine if the event that happened on R1 in New York is the same event that happened if it affected R2 in London, for example. The preferred method of doing this is going to be using Network Time Protocol, or NTP. We didn't go into that. That's a whole different lesson. This lesson just focused on the quote-unquote manual ways to configure time. As I mentioned, all Cisco devices have a software clock. Some of the newer platforms have a hardware clock as well, which is analogous to the clock in your PC. There's a battery that keeps a clock going whenever the device is not up. It's been reloaded, it lost power, it's sitting on a shelf somewhere. That's going to keep the time. But the older ones don't have this ability. So you might get set back to epic time, which is going to be March 1st, 1993 or 2002. It's going to be pretty far from your current time now. It's going to be at least 8 to 17 years old. What you're going to want to do with those devices is use the clock save interval global configuration command. And as we saw in the lesson, this isn't perfect. You can have some clock drift or slippage. Plus, it's only going to write that time to your NVRAM every X hours, with the smallest interval being 8 hours, but it's better than getting sent back to 1993. So, as I said, newer Cisco platforms have a hardware clock that's going to survive the reload and power outage. You do want to know that the software clock and the hardware clock are separate, and how those relate, and how to update each of those, or to coordinate the two different times between that, and we went through all that in this lesson as well. So the meat and potatoes from this is basically to manually set the time. You're going to use the clock set time, and that's going to be a privileged exec command. And then to view the time, use the show clock command. Everything else is just commentary. Thanks once again for joining me in the Packet Lab. As always, I hope this helps you on your route to becoming a network god.